Hello and welcome to discuss about predictive maintenance in Arctic shipping. My name is Jarkko Sirrola and I'm responsible of predictive maintenance at Steerprop. I've started my career in maritime back in 2003 and have been focusing on condition monitoring since 2010. It's been a great journey and I have become very passionate about predictive maintenance and bringing value to customers through smarter maintenance practices. I can easily say that at Steerprop, predictability, safety and productivity all add up to unrivaled reliability. Some facts about Steerprop. Steerprop is a Finnish company manufacturing azimuth propulsors to the most demanding and toughest conditions around the world. We have delivered propulsion units for Arctic, offshore, tug, workboat and cruise industries. Arctic has always played a big role at Steerprop, and in fact every third icebreaker around the world relies on Steerprop when it comes to propulsion. We operate in more than 50 countries and have delivered close to 900 propulsors up to date. Predictive maintenance. What predictive maintenance really is. I have listed 3 of my personal favorite quotes of predictive maintenance. Predictive maintenance is scientific thinking based on data. It is data-driven maintenance strategy. And last but not least, the most important one, reliable vessel is a safe vessel, is a cost-effective vessel. Now let's have a look at the situation in our everyday life. From the diagram, you can see that there are defects usually in every stage of operation, starting from the design. During the design phase, there can be defects affecting the life cycle of your product. When you buy components, there can be defects which you try to avoid by inspecting them. When you do your installation and commissioning work, again there can be defects which you try to avoid by following procedures. As an operator, there is not much you can do with these, as it is the OEM responsibility. But the last 2 boxes are the ones where an operator can make a difference. So you operate with precision to avoid the defects. In the end, all of the defects during the whole process ends up to the last box for the operator to maintain. And here you need condition monitoring to control all the surprises that can pop up along the life cycle. All of the defects, if unmanaged, will develop to a failure at some point, causing reduced efficiency, unplanned work, downtime, and injuries. The data you have available with condition monitoring will guide you with your root cause analysis and will provide the tools to address the issues and avoid making the same mistakes again. With condition monitoring, you can increase your reliability, safety, and your bottom line. But to be able to do all of this, your maintenance strategy needs to be data-driven. Why is predictive maintenance important in Arctic environment? Well, first of all, service facilities are often far or non-existent in the area where you operate. Once the need for maintenance is realized, it can be very long and harsh transit to the nearest dry dock. If the failure limits your power output, it may not even be possible to continue without assistance, so there is risk of getting stuck. Then there is the off-season. When you have the data from your equipment available to you, you can plan your maintenance to be done during the off-season. So you need to know if there are defects hiding under the surface that can cause downtime during the upcoming season. And again, last but not least comes the safety factor. The medical aid can be far, far away. Now we have mentioned safety many times, but what condition monitoring has to do with safety? Quite much actually. Safety is number one priority. I think we can all relate to this. I have here two studies and some data to back that up. The first one says that studies show that the most likely person to be injured is a maintenance technician with less than 2 years experience doing reactive work, so no time for proper planning. The second one says accidents happen 5 times more likely in maintenance work when doing breakdown work rather than doing planned and scheduled work. On the left hand graph, we can see the trend line presenting the injury rate and the blue line presenting the overall effectiveness of your equipment. And we can see that the higher the effectiveness of your equipment is, the lower is the injury rate. And on the right hand side graph, we have corrective and reactive work orders per day on the x-axis, and on the y-axis we have total injuries per year. So we see that the more corrective and reactive work orders you have, the more you have injuries. So condition monitoring increases reliability, and higher reliability increases safety simply by lowering injury rates caused by corrective and reactive maintenance tasks. Condition monitoring helps you to change the way you do your maintenance. It also gives you the possibility to plan ahead and do predictive maintenance instead of the breakdown work with fast decisions and the economical pressure on your shoulders. The more reliable your equipment is, the more safe it is to work with them. You often hear words predictive and preventive when you talk about maintenance. Here we have a classic example of predictive maintenance and how defects can be detected at early stage and how they provide the possibility for planning and timing your maintenance correctly. On the upper graph, we see the trend surpassing the alarm limit, the red line, to raise up an alarm that attention is needed. The data is then being analyzed and an outer-raised defect is detected from the spectrum shown in the below. The engineers can see straight away that the outer-raised defect that the bearing generates, shown with the purple lines, align perfectly with the peaks on the spectrum, and this is a beginning bearing defect. This is then reported to the client, and after 1 year of follow-up, the unit was brought down to a maintenance in a controlled and safe manner, and the failure was avoided. Here's an example of a preventive maintenance with condition monitoring. The lubricant is the most single factor affecting to the bearing life, and water has drastic effects to it. There are a lot of ways to measure the water content, but important to me is to understand what you really want to know. Is it really how much water you have in ppms you want to know? Or do you just want to know if it is too much or if this is okay? So simply, do I need to do something or not? On the left-hand side graph, we have water content as a ppm on the x-axis and bearing life on the y-axis. The first red dot is representing the state where the bearing life is 1, and there the water content is 100 ppms. When the water content goes up to 1000 ppm, which is only 0.1% of water, the bearing life already decreases so that you only have 25% left anymore. With lubricants, there are basically two forms of water, free and dissolved. And if you look at only the absolute ppm value, there are always some levels present. But it is hard to tell from the ppm reading whether it is free or dissolved water. Free water does more damage to a bearing than the dissolved water, and the saturation curve tells you how many ppms of water the oil can hold in dissolved state. When we look at the right-hand side picture, on the left-hand side of the saturation curve is free water, and on the right-hand side is the dissolved water. It is not possible to know the exact location where the saturation curve is, as it depends on many factors such as additives and how old the oil is, etc. But it can be measured in a way that you know from your data how close you are to the saturation point. And when the measurement tells you that you have now reached the saturation point, then you know that there is going to be free water from now on. And you can start treating the oil to get the water content back to more acceptable levels and prevent premature defects from developing in the first place. So when the water content is measured this way, you simply get the answer whether you need to do something or not. And this is a very important part of the information. So what should be monitored? We think that bearing condition is absolutely one that should be monitored so that you can pick up the beginning bearing defects. Oil condition is also an important part. You need to measure moisture. Particles are important to see how much wear you have ongoing and to detect the oil cleanness level, and also aging of the oil, which tells you if the oil needs to be changed or not. Control system signals are an important part that can be done via integration with the help of OEM. Seal condition is of course important so that you know the condition of your seals to keep the water out from the lubrication oil. Slewing rings, you can measure axial clearance with proximity sensors and detect beginning defects with acoustic emission sensors. Also, the torque is very important in ice-class vessels so that you know in what kind of environment you are operating at. I have here a small real-life example where technology and people meet. Even though the people are at the heart of our operation, they are still guided by the latest technological advancements like AI and machine learning. One of the advantages of being an OEM is that you have the exact details of your machinery available to you, and you can build a detailed model from your powertrain, shown in the lower right corner, and here the AI and machine learning steps in, automatically supporting our daily lives. For example, in this case, the model was built by our people, and based on that, the system then automatically adjusted the limits based on the baseline data available. And after 2 months of operation, the system automatically informed us about the worsened condition of a roller bearing. Our engineers then analyzed the data shown in the lower left corner and identified an auto-raised defect as the peaks on the spectrum matches with one of the bearings defect frequencies. This was then reported to the customer, and this particular customer is still operating, and we are monitoring the progress of the defect, and they still have plenty of time to react, and the most important thing is that they can calmly plan ahead of their upcoming maintenance. Monitoring center. This is where all of the before mentioned is happening at Steerprop. The heart of our condition monitoring operation is of course our people, but also our monitoring center. We use only certified analysts who provides support and diagnosis that covers everything from vibration to mechanics and controls. We have live data available in our monitoring center from the whole propulsion system, and we provide fast response times, even a real-time support if needed. In the end, what we deliver is the real condition of our customers' equipment to their attention so that they have the ability to calmly plan ahead. So, reliable vessel is a safe vessel, is a cost-effective vessel, and reliability is what predictive maintenance is all about. Thank you.